Hi, welcome back to Mrs. O'Graham's Maths. We are working through some worked solutions on this video for the D&D resource booklet for integration. So first of all, a big thank you to D&D Resources for allowing me to use their materials in this way. I have put a link in the description for this video to their website, so you can order paper copies of their booklets or get the e-flip book. I highly recommend ordering the books themselves. It's really helpful to be able to write on paper when you're doing this kind of maths. Okay, so we are looking at the integration paper. It's Practice External Assessment number 4 from their booklet. Okay, on to question 1. So if we are integrating each of these terms, integrating 4 becomes 4x. The integral of sine is negative cos. Now, because we started with a negative there, we will end up with a positive cos. The inside stays the same, but we need to use reverse chain rule. So dividing by the quarter that is inside of that means that we will multiply by 4. So this is a plus 4 cos x plus 4 plus c. Now, finding the area under this curve, we're going to integrate between 0 and 10 for this start and end point for the equation, which is cos of 0.6x minus 1 plus 0.4x with respect to x. So if we integrate cos, we get sine. The inside doesn't get changed, but we do need to divide by the derivative of that inside. So we'll divide by the 0.6. And then 0.4x integrated becomes 0.4x squared divided by 2. And we're going to enter 0 and 10. So now we'll have, if I do 1 divided by 0.6, that turns into, oops, I meant to press the other button. There we go. Let me just get back to where we were. Hang on, 1 divided by 0.6. Right, as a fraction, that's 5 over 3. I find that a little easier to deal with. So this will be 5 over 3 sine of, putting 10 into our function first. So 0.6 times 10 is going to be 6, minus 1 is 5. Then we add in 0.4 times 10 squared. So that's 0.4 times 100 is going to be 40 over 2. Take away, if we enter in a 0, we would have sine of minus 1. I'll write that in actually. So 5/3 of sine of minus 1 plus 0 for the second term. Okay, so let's pop that all in. 5 over 3 times sine of 5 plus 40 over 2 will be 20. We're going to take away 5 over 3 sine of minus 1. So overall we get 19.8. Our measurement was in meters, so that is 19.8 meters cubed. Now, if you have a more up-to-date calculator than mine, when you are at this line here, you can actually put that in as a definite integral. Because this is only an achieved question, you can use your options that you have down here to, let me just get back to here. If we go to the calculus menu, a more up-to-date calculator gives you an option here to do a definite integral where you can put the integral in, enter the numbers, and it gives you that answer. I don't have that option on this calculator, but if you've got the newer models, you can do that. Right, part C, we have another definite integral. But before we can go ahead with integrating it, we need to sort out what's happening on this term here, because that's not something we can integrate straight away as it is. So let's turn that into a fraction where we're going to do a bit of algebraic juggling to sort out what 2x over x plus 1 is. I'll just do that on the side here actually. So if I was to change the top into being 2 times a multiple of the bottom, that would give me 2x plus 2, whereas we actually only want it to be equal to 2x, so we need to take off the 2 to make it equivalent. Okay, so now that thing is equivalent, I can separate it into 2x plus 1 over x plus 1 and minus 2 over x plus 1, and those cancel. So back over to what we had with our question, we now have, I'm just going to give myself a bit more room. If we're going between 1 and 6, 2x plus 1 minus the thing that we just worked out is equivalent is 2 minus 2 over x plus 1. So just taking this bit over here and replacing the 2x over x plus 1 into this. Now we've got terms that we can differentiate, or sorry, integrate. 1 to 6, 2x, 1 minus 2 is minus 1, and plus 2 over x plus 1. So the 2x becomes x squared. The 2 would get divided by the 2 like that, so they cancel. Minus 1 is going to become an x. Anything over a singular x is logs, so this will be 2 log, because we bring the 2 outside, make it 1 over x plus 1, and then that integrates to log of x plus 1. We're doing that between 1 and 6. Okay, so now substituting in, if we put 6 into that, so 6 squared minus 6 plus 2 log of 7, that's 33.89, minus, if we put a 1 into it, we've got 1 squared minus 1 plus 2 log of 2, so minus 1.386, and we'll subtract them. So 33.89 minus that one gives me 32.5. Okay, part D. For this one, we're being asked to find this area here that's been filled in on the diagram, which means we're going to need to integrate between the curves, and we'll need to know where they intersect. So let's find these intersection points. We need the x values of those. So that will happen when sec squared x is equal to 8 cos x. Now sec squared is 1 over cos squared x. So then we'll have 1 over 8 is equal to cos cubed x. So cos x will be the cubed root of 1 over 8, which is a half. Now, half is one of the special values. If we try and do the inverse cos of a half, you'll get that answer there, but that's not very helpful. We want an exact value, right? Because in our question we have an exact value here. So looking at the special triangles, we have one that looks like this. It's a 1, a 2, and a root 3. So we're looking for cos, where cos is to do with the adjacent and the hypotenuse. So it's going to be this angle just here. That will give us 1 over 2, and that one on our special triangles is pi by 3. So x is plus or minus pi by 3. I get the plus one just from being the simple pi by 3 answer. The minus one is from knowing that cos, the cos graph does this shape here. So I'm just trying to squeeze it in. So we know that it's symmetrical about the y-axis. So our solution will be that the left one here is also symmetrical and gives me a minus pi by 3. Okay, so now let's move on to find the area. let's go with a blue to match the shading. So the area then will be the integral between minus pi by 3 and pi by 3 of the subtraction of those two curves. Now the top one is the 8 cos x, and we're going to take away the bottom one. This bit here is the sec squared. So if we integrate those terms, cos integrates to be a positive sign. So we get 8 sine x. Sec squared integrates to tan x. That's on your formula sheet. So we have a minus tan x here. And then we pop in the values of pi by 3 and minus pi by 3. Okay, now if I do sine of pi by 3, we need exact values, so we can't just type this into the calculator. Going back to that special triangle, sine is the opposite over the hypotenuse, so that's root 3 over 2. So we have 8 root 3 over 2, and then tan of pi by 3 is the opposite over the adjacent, so that is a root 3. Right, take away, if I was to do the negatives. So now we can think about putting the minus pi by 3 in by thinking about where it is on the graphs, but that's probably going to take a little longer. We can save a bit of time by just putting it into the calculator and knowing that it's going to be of the same size as the ones that we just worked out. We're just going to check if they're positive or negative. So if I do sine of negative pi divided by 3, I get negative of this answer. So where I previously on the first one would have done that pi by 3, if I put in a negative pi by 3, then sine of that answer gives me the negative, and it'll be of the same size. So I know that this will be a negative 8 root 3 over 2. Let's do the same if I'm doing tan. Let's go back up here. Tan of that is a negative, where previously I had this one. So popping in the negative is going to be the same size, but negative. Now you do need to check that because it doesn't just automatically switch positive to negative because of how the curves work. But this one was fairly straightforward. So we're minusing a minus number, so that becomes a plus, and that will be root 3. So this now is 8 over 2 becomes 4 root 3 minus root 3 plus 4 root 3 minus a root 3. So we have a 4 plus a 4 is 8, and take away 2, it leaves us with 6 root 3. For part E, we have a situation where the rates are proportional, and the intensity of light is a decreasing sort of proportionality. We need to write down the information we've been given about that proportional relationship first, which is that the rate at which the intensity of light changes, so that means the rate at which the light is changing over time. My apologies, I was assuming time. It's not actually time, it's over the distance, because it changes according to the amount it's moved in x. But that rate is proportional to, which means we write it as equals to a constant k, and then it's proportional to L itself, so the light intensity itself. We write that as this. Now I'll take you through the steps. We look at this as separating variables. So dl stays on the left. We move the L that's on this side over to the left-hand side, do it 1 over L, leave the k here and bring the x over this side. Now integrate both sides, and what we'll have is the natural log of L is equal to kx plus c. Now, when you've done lots of these, you don't actually need to write that middle step in. You can go straight from this to this, because these are very common types of problems, and if you've memorized that step, you don't need to show the middle piece, but you do need to know that it changes into natural log of L is equal to kx plus c. Now, if we take e of both sides, that helps us to get rid of the natural log on the left, so we've got L equals something. Now, if we have e to the kx plus c, that's the same as if I was to do e to the kx times e to the c. Now, e to the c is itself a constant, so we just write that as a e to the kx, where we've turned this into the constant a. Again, if you can memorize these steps, you can go straight from this all the way down to writing down this final equation of L equals a e to the kx. So doing a lot of practice of this can help you get straight from that to that. Okay, next bits. Now we use the information in the question to help us to figure out what a is. So let's start. Usually you start with the initial values. So when x is 0, when we haven't moved at all, we've got the intensity is at its regular amount of being 100% intensity. So L is equal to 1. We tend to turn them into decimals rather than percentages, so 1 being equal to 100%. So then we have 1 equals a e to the 0. E to the 0 is just 1, so a equals 1. The other bit of information that we have is that at 6 meters we've got half the amount of light. So that'll help us to work out the other piece, the k. So when x equals 6, L equals 0.5. So we have 0.5 equals e to the k times 6, which is 6k. So now if we take log of both sides, 6k equals log of 0.5, and k equals 1/6 of that. Then finally, let's work out when we hit the 10%. I'm going to carry on over on the right hand side now. So when L equals 0.1, we're going to have 0.1 equals a e to the kx, where a was 1. And then we do e to the k, which is 1/6 natural log of 0.5 times x. Actually, let's write that out in full, just to make it clear that the x is not part of the natural log. Now take log of both sides. We get log of 0.1. The log cancels out the e, so we have x over 6 log 0.5. The rest I'm going to jump straight to the calculator and work that through. So log of 0.1, we will multiply it by 6 and divide through by log of 0.5. So x equals 19.9 meters. Now before integrating this one, we'll just change it into 9e to the minus 3x minus x cubed dx. E to the x doesn't change, but we do do the reverse chain rule on it. So where we would normally have multiplied by minus 3 if we were differentiating, we need to divide through by the minus 3. So 9 divided by minus 3 is negative 3, and then e to the 3 minus 3x. And then x cubed becomes 3. No, it doesn't. It becomes x to the 4 over 4 plus c. Let's start by simplifying for part B. So 6x over x to the half. If we're dividing powers, we subtract them. So we've got a power of 1 at the top. 1 minus a half is a half. So this is 6x to the half. So the integral then becomes 4 to k of 6x to the half, and it will be equal to 76. So if we integrate 6x to the half, we are going to raise the power by 1, so that'll be x to the 3 over 2, and then divide by the new power. So 6 divided by 3 over 2 is going to be 4. Now we pop that into a definite integral between 4 and k, make it equal to 76. So 4k to the 3 over 2 minus 4 times 4 to the 3 over 2 equals 76. So let's do 4 to the power of 3 over 2 times that by 4 and subtract, let me do this one bit at a time. 4k to the 3 over 2 minus 32 equals 76. So if I take the 32 over here, we can add it on like so. So 32 plus 76 is then 108. So k to the 3 over 2 is 108 divided by 4, which is 27. Now we do it to the power of 2/3 to undo where we've got a power of 3 over 2, and k equals 9. Okay, we're told that this area that's been shaded is equal to 5. So if we do the integral in question just here, then we'll set that equal to 5 and we can work out the value of k. So if we integrate between 1 and k of 4x squared over 2x cubed minus 1, we will get the answer of 5. So this then leads us on to the next step to do this particular integral just here. That's going to be the natural log function, because the top is something to do with the derivative of the bottom. If we differentiate 2x cubed, differentiated would go to 3x squared. Oh, no, it wouldn't. We would have 6x squared. Now that 6 is not quite what we wanted over here, where we have a 4. So we have to work out what we'd times this by to bring a 6 down to a 4. Well, 4 is 2/3 of that. So if we do 2/3 of that, it would end up being 4x squared. So the answer that we want to start with is going to be 2/3 of the natural log. So 2/3 natural log of 2x cubed minus 1 for what's in the bottom of our fraction there. If you were to differentiate that, you would get 4x squared over 2x cubed minus 1. Now we put in the values of 1 and k and set that to be equal to 5. So we have 2/3. I'm actually going to take that outside of the bracket entirely. We can do that with constants. So we're left with log of 2k cubed minus 1 minus log of 2 times 1, which is 2, and then minus 1 is 1. Now, log of 1, if you pop that in your calculator, you'll see it's just equal to 0. So then we have log 2k cubed minus 1 is equal to, if I do 5 divided by 2/3, we get 15 over 2. 2k cubed minus 1 is then e to the power of that. Let's say that's 7.5, make it easier for me to fit in here. So e is e to the power of 7.5, so k will be, let's pop that in the calculator because it's not going to give us a nice fraction. We can just go straight into decimal. So e to the 7.5, we're going to add on 1, then divide by 2, and then we want the cubed root. So k is 9.67. We've got kinematics for part D, where our acceleration function is given as 2 times t plus 1 to the minus a half. Velocity will be to integrate that. So if we integrate that function, we are raising that power by 1, so that will become a half, and divide by the new power. T divided by a half is 4. Now we're told that when t is equal to 3, the velocity equals 4. So v of 3 is 4, 3 plus 1 to the half, plus c, and we're told that's equal to 4. Now 3 plus 1 is 4, to the power of a half is 2. 4 times 2 is 8, so 8 plus c equals 4. So c must be negative 4. Next is working out when will it reach a velocity of 12. So we want to set our velocity function to be equal to 12. So we have 4 t plus 1 to the half plus c, which is minus 4, equals 12. 12 plus 4 makes 16, then divide it by 4, we've got 4, so the square root of t plus 1 is 4. Square that, we've got t plus 1 equals 16, so t equals 15. Part E, we're using this formula that's given to us to work out surface area. Now the pieces that go into that formula, we've got our f of x function just there. Let me just sort that out. So the f of x is given to us as x cubed. Then we need to put in f dash of x, which will be to do the derivative of the f of x function. So let's work out what we've got there. Oh, and the a and b part here, so the beginning and end of our limit, we're told is x equals 0 and x equals a. Let's write what we can into the formula for the surface area. So that will be 2 pi times the integral between 0 and a. F of x is x cubed. Then we have the square root of 1 plus f dash of x, which is the derivative of f of x, so that's 3x squared. All I'm doing is differentiating that bit. That gets squared. Okay, so let's work that through. This becomes 2 pi integral x cubed, and then 1 plus 9x to the 4 to the half. Now, since this outside part is 1 less power than this inside part, what we've actually got is a reverse chain rule. If I was to do chain rule on this, just this section here, the bit that's square rooted, it would spit out an x cubed if I was differentiating it. Let me show you what I mean with that one. These ones are fairly difficult to spot. So if y was equal to 1 plus 9x cubed, 9x to the 4, and we raise the power of a half by 1, we would have a 3 over 2. If I was to then do dy by dx, the 3 over 2 would come down, and the 3 over 2 would take a power off of that, and it would be a half. And then we would times by the derivative of the inside. So 9 times 4 is 36, x cubed. So overall, if we did 36 times 3 over 2, we'd have 54. So this is 54, 1 plus 9, x to the 4 to the half. Oops, I missed out the cubed. 54x cubed. Okay, so this here, now comparing it back to what we had, well, we have the x cubed part, but it's not as big as 54. So the actual answer that we're looking for over on the pink side of stuff is 54 times smaller. So it'll be 1 over 54 of this thing that we started with. and we're doing it between 0 and a. Okay, so now if we put those limits in, we would have 2 pi being times by 1 over 54, 1 plus 9a to the 4 to the power of 3 over 2. If I put a 0 in there, we would have 1 over 54 times 1 plus 0 to the power of 3 over 2. And we're told in the question that this area will be equal to 4 pi. So we set this to be equal to 4 pi. We move this purple bit out of our way. Okay. All right, so continuing on with this, let's divide both sides through by 2 pi. We'll have 1 over 54. We're going to take that out as a factor of this left-hand side, like this. Dividing through by 2 pi gives us just a 2 on the right. So then 1 plus 9a to the 4 to the 3 over 2 minus 1 will be equal to 2 times 54, which is 108. So 1 plus 9a to the 4 to the 3 over 2 will be 109. So if I do the power, 109 to the power of 2 over 3 to undo the 3 over 2 power, gets us a decimal. So 9a to the 4, we take off 1, divide it by 9. Oh, let's write that bit down, middle step. So divide it by 9 and do it to the power of 1/4 to find that fourth root. And a is equal to 1.25. You could also, at any stage in this working out, to work out the value of a, you could use equation solver, this function on your calculator. If you don't want to go through all of the steps there, you can type one of these lines in and get it to equation solve for you. So there's the whole of that one on one screen. For question 3a, we have a reverse chain rule here. So we will increase the power by 1, which gives us a 6. We divide through by the new power, so 6 divided by 6 is going to be 1, but we also need to divide through by the derivative of the inside, so overall we'll have a half at the front there. Part B, we've got a rate expressed by this equation just here, so we need to integrate it to find a. So integrating e, the function itself stays the same, but we need to divide through by the derivative of that power. So the derivative of the power is half, so 0.2 divided by a half is 0.4 plus c. Now back to the question to get some information so that we can work out the c. So we'll start with t being in the time in days, a is the area, and so I don't like making assumptions, but for this one we're going to assume that it starts from nothing so that we can work out the c. So when t is 0, a is 0, so 0.4 e to the 0 plus c is equal to 0. So c is minus 0.4. When t is 2, because we're going to work out for 2 days and 4 days. Let me just move that out of the way. Then we've got the area will be 0.4 e to the 1 minus 0.4. When t is 4, the area equals 0.4 e to the 2 minus 0.4. Let's call that area 1, area 2. The difference we're looking for between those 2 days, A2 minus A1, 0.4 e to the 1 minus 0.4, take away 0.4 e squared minus 0.4. It's a difference of 1.868, and I just realized I put it in the calculator backwards because I did the day 2 one first, but just if that happens to you, just recognize that you put the subtraction in the wrong way around. We'll just change that to a positive, and that's being measured in centimeters squared. Part C, let's start by rewriting this in line so that it is 4x plus p squared to the minus a half. So that is going to, we're going to increase that power by 1. It'll be a half. If we divide by the new power, then we are timesing by 2. But then we also need to divide through by the 4, that's the derivative of the inside. So this will end up being 2 over 4, which is a half. The inside remains as it is, and remember that p is just a constant. That can often trip people up, and you might be tempted to try to differentiate or integrate that thing too, but just leave that as it is. It's just a number. We're doing that between 0 and 6p squared, and it's equal to 16. Now we can actually take the half outside of that, so I'm going to do that. And then we would have, if we pop 6p squared in for x, we would have 4 times 6p squared plus p squared to the half minus 4 times 0, so then just p squared to the half, and that will be equal to, if I take the half over and multiply by 2 on the other side, that's going to equal 32. Right, so this bit here we've got, if we multiply that out, that's 24p squared plus a p squared, so that's 25p squared. So we're now doing the square root of 25p squared minus the square root of p squared. So if we square root that, we get 5p minus p. So 4p is 32. So p is 8. For part D, we are solving this differential equation, and we need to do that by separating the variables of h and t. So if we start by bringing h over to the left-hand side, we will have 1 over h squared dh, and leave the minus 1 over 5 where it is, bring the dt over to the right. Now we can integrate both sides. So 1 over h squared is h to the minus 2. So if we integrate that, raising the power by 1 and divide by the new power, and then integrating minus 1 over 5 is minus t over 5 plus c. Now let's look back at the question for what will help us to work out the c, and it's this here, that the initial depth will be 1.5. So when t is 0, h is 1.5. So we have minus 1 over 1.5 is equal to 0 plus c. So c is minus 1 over 1.5. Well, 1 divided by 1.5 is 2/3. So c equals negative 2/3. Okay, to finish this one off, we're looking for how long it takes for the depth to get to a height of 10 centimeters. Now, there's a little trick in this one. They've given us the height in centimeters, whereas before we've been working in meters. So very easy to miss this one. Make sure that you are putting the height in meters. So when h is 10 centimeters, it'll be 0.1 for our equation because that's 0.1 meters. Putting it back into this line here, we then have minus 1 over 0.1 equals minus t over 5 minus 2/3 for the c. So if we do a negative 1 divided by 0.1, then we add on 2/3 and divide by a negative 1/5 and turn that into a decimal, then t is 46.7 and our time was just here in minutes. Okay, if we're finding this shaded area, we need those points of intersection so we know the limits we're integrating between. That happens when x squared equals a squared minus x squared, setting those two equations equal to each other. So 2x squared equals a squared. So then x squared is a squared over 2, so x is plus or minus the square root of a squared over 2, which is plus or minus a over root 2. So this one here is a over root 2, and this one here is minus a over root 2. Now, since that's symmetrical, I'm actually just going to do it for one side and then double it. So the area will be 2 times the integral between 0 and a over root 2. And the reason to look for those sorts of symmetries is because oftentimes when we put a 0 in as a limit, it makes things a lot easier. Okay, now the area that we're doing is the top curve, which is a squared minus x squared. Take away the bottom curve, which is our x squared. So tidying that up, we get a squared minus 2x squared dx. Remembering that a squared is just a constant. So if we integrate that now, we get a squared x. The x term we increase by 1, we divide by the new power, and we're putting in our limits of 0 and a over root 2. So this is now 2 times by, if we pop a over root 2 in first, we'll have a cubed over root 2 minus 2/3 of a cubed over root 2 cubed, which is 2 root 2. And the 0 term, if we were to put that in, just comes to 0 on each of those bits. Now these 2's cancel just here, and what we end up with is 2 lots of, we've got an a cubed over root 2 minus 1/3 of that same thing. So it'll be 2/3 of a cubed over root 2. Or we can write that all as one fraction so that it's like this. Which then becomes 4a cubed over 3 root 2. And there's that one all on one page. And that finishes off that paper for us. If it was helpful to you, please like and subscribe, share, comment. It helps other people to find it too. Take a look at my homepage and see what else you might find useful as you're studying this topic.